out while you're studying, try to isolate like what particular part you're having trouble with, right? So when you're looking at your quiz and you're looking at the solution, don't just go, well, okay, this is the right answer. What you should be doing is looking at your solution and going, what specific steps did I miss, or what did I do differently from the solution, right? That'll help you kind of isolate. Usually it's just like a small part of the idea is missing, and people get stuck with that. Just going to mute. Okay. So let's go through the quiz first, and then what I'm going to do for the second part of the class is just run through like a overview of what you can expect on the exam. I don't think this will be a super long class. I'm going to try to get through it pretty quick, and then if you have other questions, you can ask. Thanks to everyone who showed up this weekend for the bonus sessions. They were really good. I think people got a lot out of them, so it's great. And okay, so let's get into the quiz. Just as an interesting aside, this is how I have to encode your exam. So I have to like put it into this like quiz category, and then I use sort of weird markup syntax. So when you're getting typos on the exam, it's because if I give you questions with text, so say I want to write a class, like a public class test, I actually have to, remember we talked about escape characters. I actually have to escape the characters here of this, and also of stuff like in I equals. Well, equals is used in the multiple choice answers, so I actually escape that as well. So it makes it really kind of weird to code stuff. So anyway, just a little aside. Okay, question 1. Write a method for a linked list with int nodes, like in A3, that will return the data from the second node of a given list. It should properly detect if no such node exists to avoid errors. Okay. How do we get the second node of a linked list? Well, you all blurt out at once. The simplest way to do it is to, the simplest way to do it is actually get, or top.get link. Oops. Okay. And the reason for that is that when we're talking about linked lists, top is referring to the first node in the list, and then get link is getting the link from that node. So you can really say get the first node in the list and then get the node that it points to. Now, what do we have to do to make this an actual answer instead of just like the proof of concept? So this is something I was talking about the other day, is like when you're coding, often what you want to do is like figure out the proof of concept. What I mean by that is like if my list has 2 links, this will retrieve the second one. And then what I want to do is kind of work backwards from there. Now that I've proved I can get the link, now I'm going to work backwards and I'm going to check all the things that could go wrong. So what could possibly go wrong in a linked list trying to access the second node?
If there's no second node.
Okay, if there's no second node, how do we check for that?
If the top is null.
Oh, we've got a bit of echo.
Yeah.
Yeah, like if top is null, that's an issue. Or if top dot get link is null, right? So what I have here, let me find it, get second. Okay, so here's my get second. So I have something like this. So this, again, here's my, now in this case, you have to be careful because what the question asked for was return the data from the second node of a list, right? So this will return the second node from the list, but be careful. The type given here is the data, which is an int. a lot of people, this is starting to get into exam stuff, a lot of people tend to lose marks for this kind of mistake, right? So you're so focused on getting to the goal that you miss the details along the way. Yeah, do you have a question? Yeah. Oh, I'm not sharing the screen. No wonder you're having trouble. Sorry about that. Okay, sorry. So what I was saying is basically like this will get you the node, right? And this is kind of like the proof of concept. Like this is like the simplest path to the goal, but it doesn't do any error checking. What's useful about it though is it allows you to kind of prove your point. Like, okay, this is how you access that node, right? Once you get the node, refer back and it's you see, okay, well, I actually need to get the data from the second node. So what I actually want to do is get link. Now this will give you the node, and then to get the data from the node, you're using get data, right? So now this is returning an int, and then all you're basically doing other than that is adding some error checking. So you want to check all the things that could go wrong. So the first node could be null, so top equals null, or top dot get next could be equal to null. The second node could be null, right? So I'm just checking those two. I didn't really specify in this case, so I just returned -1 if it was null. I usually will specify, or make your judgment if I don't. So something like this. Okay. A lot of people had like really complex structures here. I like this question because it really shows me like, are you understanding how a linked list works? You shouldn't be treating it like an array. One of the really common errors people have with linked lists is they start thinking in terms of indexes. You could do that, like alternatively to this, you could do something like, if you have a size method, for example, you could do something like if size is greater than 1, or if size is less than or equal to 1, return -1. Something like that would work as well, and size is just going to like iterate through the list. But I think in this case, this is probably cleaner. Okay, any questions? No. Okay, this one's a little trickier. Write a method for a linked list that will return the data from the second last int node of the linked list. Again, we're returning data. So if you're thinking about this, you lose some marks. You probably won't lose a lot. So it might be like half a mark worth. Like I said, most people lose marks not on this part of it. They lose marks on this part, or they lose marks from not returning the data, right? Like I bet you 80% of you will get this part, or 90% maybe. I bet you 70, 60% will get this part, right? And I bet you 45% will get the whole thing. So when you're doing your exam, like I said, one thing you really want to try to do is leave yourself time at the end to double back over and just review everything. And what I want you to do there is just look at it with fresh eyes, read the question. I'll give you like a bit of a checklist you do. Make sure you're returning your data. Make sure it's the right type of data. Make sure you're checking for null references before you access it. Make sure you answered all parts of the question. That was a big one in the midterm. A lot of people, I had multiple questions. So like a common type of question I might ask is something like, what is an advantage of using a linked list with a search method or something, right? And then I might also say, what is a disadvantage? Or I might say list 2 advantages and 2 disadvantages. And lots of people only halfway answered the question. It's frustrating because I can see from your answer that you understood the material. You're just not finishing reading the question. So I really want you to make an effort on the exam to like if you have to just make a little to-do list, like things to check on the exam before I hand it in, right? And I know when you're done, you're going to want to like get it off your plate as fast as possible and just to say good riddance to 1020 and move on with your winter holidays. but I really want you to like take a deep breath before you hand it in. You know, if you have to just like sleep for 5 minutes or like just clear your head for a couple minutes, you know, take a quick break and then just review everything. Just double check that you answered the questions correctly, because a lot of marks get lost that way. It's sort of frustrating to see because I know you guys know better. So all right, anyway, I'm ranting a little bit now. So let's go back to this. So write a method for a linked list that will return the data from the second last int node of the linked list. So we're returning data, so our return type is going to be int, right? So I would put this in right now. Put it in right at the beginning. I'm going to say get, you know, second, last. There we go. I'm going to also, something I like to do is I would add in int answer. I put this in first so you don't forget, right? Because now you won't forget. Now you have a variable you're returning an int. This alone is probably worth a half a mark, right? So how do we know when we're on the last node of a linked list? If what is equal to null? If top is equal to null? If top is equal to null, that means the list is empty, right? Because our linked list, where is my, sorry, I got too many things open. Our link, oops. It's like this. Here's some nodes. There's my nodes. Here's top. Okay. So if top is null, what that means is your list is empty because there's no node. So the top pointer is empty. So what we're really looking for, we know we're on the last node. Top.getLink equals null. No, top is always pointing to the top. Okay, so what we're doing is we're making a second pointer. Usually this is called next, but it might be different things. It doesn't really matter. And we're saying next equals top to start. And what that's going to do, I'm going to put this in a different color just so you can sort of read it a little better. Put this in red. So what next is doing is next is keeping track of our position. We're moving next over as we go. Okay. Top always points to the top of the list. If you assign top somewhere else, you just lost your entire linked list worth of data. So you have to be really careful with that. So what we're really looking for is when next is on the last node, its next is null. Okay, so this would be null. Okay, does this make sense? Yeah? Yeah, well, new node.getLink is not equal to null. New node equals new node.getLink. Yeah, okay, well, that'll get us to new node.getLink. So let's look at that. Did you post that privately or should you share? I'm gonna repost this. Okay, so let's see. Is this correct? So we have int node top. Well, new node.getLink is not equal to null. Okay, so new node. Why is this not working? There we go. So new node. Now in this case, they use new node instead of next, but they're really the same thing. So well, new node.getLink is not equal to null. So what's new node.getLink? Well, new node dot now we're referencing this object. Dot getLink is talking about this reference. Okay. So if this is not null, we're going to move the pointer over one. This is not null. We're going to move the pointer over one. You can ignore this other one. Okay. So at this point, we're pointing to the last node in the list. and new node dot get link is null. So our while loop ends. So what you posted there, return new node dot get data final line. Okay, so that would give us the data. Let's just say it's 6 in our node. Now you have to be careful because the question was asking for the second last node, right? So that would actually get us the last node. What we want is the second last node. So let's just think about, yeah, there you go. Oh, yes. So let's just think about this, right? So if we're pointing to this node, let's just assume we've already got to the second last node first and work backwards. That's sometimes a little easier. So I'm going to assume we're already pointing at the second last node. Now tell me what the characteristics of it are. So we have the second last node. If I say second last dot get link, what we're really getting is this value, right? We're getting the link stored in that node. What we want to check is this value, right? That's the one that's going to be null. So how are we turning this into this? Yeah, we could say, yeah, there you go. Well, new node.getLink is not equal to null. Previous equals new node. New node equals new node.getLink. Yeah, so this would be an alternative way to do it as well. Yeah, you could use a previous node that was one. So this is an alternative. Is whoops, that wasn't what I meant. So you could do this two different ways. You could either go to the last node of the list and then keep a previous pointer that points to the one behind the current one. That's totally valid approach. The other approach is you could just loop through the list until second last dot get link is null, right? Because second last is this pointer, get link is this pointer, and now if I take these two, that's really a pointer to this object, and so I can check it's null. Right? This should be intuitive to you at this point. Does this make sense to everyone? Okay, so what else do we have to do now? If we know how to check if we're at the end of the linked list, what else do we have to check here? What conditions would cause this to fail? Yeah, so if we have only one link in the linked list. So let's think about it maybe more broadly. So what's the smallest linked list that we can have a second last node in?
Two.
Yeah, it's a linked list with two nodes. So what are two conditions that we have to check for? Well, if top is null and our list is empty, then we obviously don't have a second last node. And now I'm doing a little bit extra error checking here. I didn't need to check all these. But you could also say, like, if top equals null or top.getLink equals null, And then you don't have to do all these error checking. You could just do something like this. Right? So I'm still stepping along one node at a time, but I'm just checking whether get next dot get next equals null. And these two are checking, is there at least 2 nodes minimum in the list? And then I'm returning the value. So again, I'm working from the specific goal backwards. So I know I need to get to the second last node. So I'm just going to draw what it looks like when I'm pointing to the second last node. Then I'm going to take a step back. I'm going to go, okay, once I get there, what's my return value? And before I get there, what places am I going to run into issues with? What situations, right? And this is kind of a good way to approach these problems because it stops you from getting overwhelmed about like all the steps you need to be doing because it kind of puts them in order, right? I have the answer. What's the output? And then also what's the testing I need to do in order to get there? What conditions fail? All that sort of stuff. So I would start kind of like here and then work my way back. Does that make sense? Any questions? No questions? Everyone's good with this? Okay, great. Looking forward to marking all your exams, which should all be 100%. Okay. Question 3, this one's a bit tricky. Write a recursive method that finds the sum of all values in the linked list. Assume the linked list holds int node nodes as in the assignment. Okay, find all values in the linked list recursively. How do we tackle this? Okay, what's the base condition?
Can we get the method and parameter?
Can you get the method parameter? What do you mean?
Like, should the method have a parameter? It's
What do you think?
recursive. It should be, because otherwise you can't do it.
Okay, well, there you go. You just answered your own question. Right? Okay, I want you guys to be careful. This is a common problem I'm seeing. Top always refers to the front of the list. Okay? You're copying the value of top to a temporary node that allows you to step through it. But if you edit top, your list is broken. You lost all your data forever. No undo. Gone. So get it into your head that you're not changing top. Unless you're editing the list, you're not changing top. So top just gives you your starting value. So what would be a base case of recursively going? So let's think about this. So if I'm doing this recursively, what I'm really saying is recursively step through the list one node at a time.
I guess it will be like this, the same as any base case in a node in a linked list. Just if the parameter of which of type node is null, that will be the end of the list.
Okay, so our parameter type node. So we have, what is that parameter? Let's see. So we're returning a value. So we can start putting our method together. We can say that we know it's going to be a value because we know it's the sum of ints. So we know it's going to be int, right? Cursive sum, I'll call this. Okay. We also usually, in this case, we would want to have a method that doesn't have any parameters because it makes sense to just call on a linked list and say, hey, what's your sum? Without having to specify anything, right? So we should at least have a base version of this method. Now, you're right about the parameters. We're going to want to have another version of this method that does include some parameters. What would the parameter be here if we're talking about a linked list and we're trying to step through it?
Probably node.
Probably node. Okay. So let's put a node in there. Now this would be an int node because it's talking about the assignment. Right? Watch all these little steps, all these little things I'm pointing out where I'm pausing and I'm thinking about what this should be is all the places you guys make mistakes. So not only guys, sorry, I'm gendering you. All you people make mistakes. Okay. Women make mistakes too. Okay, so we have if, I have an else. So one of these is going to be, let's say this is our base case. So if let's just think about how we're stepping through the array first. I also have this other version of the method. So what's this other version going to do?
It will call this method.
It's just going to start us off. So how do we recursively step through a linked list?
Maybe give the same method. Like if we the method that has no parameters, we'll give it the top of the linked list.
Okay. So
And
recursive
then-
sum, and we give it top. So that's our first node, is what you're saying, and we want to return that when it returns because that's our solution.
Yeah. And then else for the recursive method, I guess we return like top or not current get link.
Get
Or wait,
data.
Well, let's be careful. What are we talking about here? Are we talking about going through the list or finding our answer? Because they're
we
two
will
different
add
things.
the data to after like calling the method again.
Let's just think about how do we get through the list first. Let's just think about the basic structure of recursion before we worry about the solution. We know we need to step through each node in the list. So let's just focus on that for now. Sorry, what were you saying?
Like for this, we are returning int, so we both have to get like
On the recursive part of it, because that's kind of trickier. And once we know how we're stepping through the list, it'll be easy for us to figure out how to get the data from the list.
Yeah.
I'm just breaking the problem. Look, I'm just breaking the problem into smaller problems, right? That's the principle of computer science. So we're not actually returning the get link here. This is our current position. So let's just think about this. We call this, we give it top. This points to the first node in the list. What's our base case at this position?
null.
What is null?
Current equals null.
Yeah, so if current equals null, what are we doing?
Return 0.
Yeah, return 0. The sum, now this is going to depend on the type of question exactly, but in this case, we can say, well, the sum of a null node is 0. That's fine. We can add that to the sum. So this is going to be our base case. So what's our recursive case now? So we know, because it's recursion, we're calling the same method again. So I can put that there. And I already have current.getLink, so the cat's out of the bag. So if I want to call this recursively, what I'm really doing is I'm giving it the next node. Right? So we're still stepping through the linked list kind of the same way we did before, but what instead we're doing, and that's part of the reason I did this top version first, because this kind of helps you understand what it's doing. We're really saying, starting at this node, find the sum of the rest of the list. Right? So starting at current, find the sum of the rest of the list.
we just said current get data plus recursive sum current get link will be it.
What's that?
If we said like current get data plus like recursive sum current get link will be it, I guess.
Something like that. So recursive sum, yeah, we just want to actually give recursive sum current.getLink.
And then before it or after it, doesn't matter. We will say plus current.
Yeah. Now sometimes it does matter, so you have to be careful. If I said I want to print this out in order, it matters, and we can look at that one in a second. But in this case, it doesn't really matter. I'm going to put it before, I think, anyway. So what do we want to do here? We want to get the sum of the current node, right? So we're going to say current dot get data, and I'm going to add that to the recursive call. So what I'm really saying here is, oops, take the value in the current node and add it to the sum of the rest of the list. Right? And that's consistent with what we're doing here. We're saying find the sum of the list starting at the top. Then we're saying, okay, well, if our current node is not null, then we're going to add the data in the current node to the sum of everything else in the list. Now let's check this for some common issues. So let's say our list is empty. Does this handle that? Yeah. So if the list is empty, top is null, current becomes top, return 0, we're done. Okay, what if there's one node in the list? Well, top is a valid node. This fails because current is valid. We're going to add the value in that current node to recursive sum. Recursive sum current.getLink. This one's going to be null. So we're going to go up here. This will be null. I'm going to go to here. That will be null. I'm going to return 0. So it becomes add the data in the first link of the node to 0. So that works. So that looks pretty good. And if we have more than that, it'll sort of do the same thing as well. Is there anything we're missing here? Mm-hmm. We're adding to the data. Well, we're not adding to the data. Well, current.getData is the data in the current part of the node, or in the current. So if this is our linked list, okay, our messy linked list here. Let's just erase some of this. Okay, so we're starting out with current pointing to top. Okay, and I'm going to add some values here. Let's put them something nice and bright. So let's say this is 5, 7, 2, this one's 6. Okay, so what we're really saying here is take the data in the current node and add it to the recursive sum, the rest of the list starting at the next node. So the way this is getting kind of calculated is we're saying 5 plus the sum of now current.next is this node, right? So we're really saying 5 plus the sum of 7 to like everything else in the list. And then this one is going to be 7 plus the sum of everything else in the list. And then that one is going to be 2 plus the sum of everything else in the list. And that one is going to be 6 because that's our last node. Sure, try again. It's current.getLink is this arrow here. Current.getLink is a node, right? We're passing a node to recursive sum. No, current in this version of the method is this green one. So current.getData is the value 5. Current.getLink is this arrow here. So what we're really doing is we're saying 5 plus this, the recursive sum, I'll just say RS, of this link right here, of that. Right? And then this one is going to just say, well, 7 plus the sum of everything else. And this one's going to say, well, 2 plus the sum of everything else. This is what the advice of, like, when you're dealing with recursion, just try to think of it one step at a time and don't try to think through the recursion. Your brain is not really that good at thinking about recursion, which makes it hard. Just focus on the step. So we know that this method will find the sum of the list starting at a given node. Right? We know that because we wrote it to do that. That's what it's supposed to do. If the list is empty, we return 0. If there's value in the list, we get that value, and then we find the sum of everything else in the list besides the current node. Right? You're welcome. What else I got here? Find sum. Yeah, so this is basically what I have here. So top equals null, return 0. Return find sum top. Oh, did we forget to do that? Well, I just did kind of the initial base case, I guess, up here. So this was kind of optional. I don't even actually need that. Private int find sum. So if current is null, return 0. Otherwise, current.getValue plus find sum current.getNext. Okay. So there's a similar pattern. Linked lists are actually a great tool for learning about recursion because they're kind of recursive already, right? We're talking about going through the list in a particular order. We can get an object reference to a particular place in the list. They're very recursive, kind of easily. I also threw a toString in here you can look at, which is kind of the same. You can see, like, if my current node, so it's a little tricky because basically, like, I'm checking the top separately. So if top is null, I'm returning no nodes found. But if top is not null, that means there's at least one node in the list, right? Which makes it actually quite a bit easier. So now we know top is not null the first time. So I'm saying if the current node dot get next equals null. So this is similar, but checking the next node in the list as opposed to, like, going all the way to the end and adding null. And they're kind of equivalent. Like, I could have done this the same way that we did the other one. It's just sort of a matter of preference or whatever. Depends on the problem. In this case, I particularly wanted to have, like, this little bracket to close out the bracket. And I'm adding it to the string of the next node in the list. So it's functionally almost the same thing. Okay. Do you guys want to take a quick break here before we move on? No? Okay. Well, let's just start as this goes. Depending on how many questions you go, this could be slower, it could be fast. So, okay, so I'm just going to run through what you can kind of expect on the exam a little bit. So feel free, if you have questions, feel free to ask. I'm not going to give you, like, explicit answers, but I can give you some insight into what kinds of questions I'm probably going to ask and what I'm expecting in terms of marking and stuff. Oops, what's going on there? Okay. One thing I also would draw your attention to here is there's actually not that much material once you all flatten it out. Each of these concepts is a little bit tricky to wrap your head around, but there's actually not that many things here. So when you're studying, what I would sort of do is use this as a guideline and just sort of make sure you know how to answer all these questions. Another couple of tips. One thing I notice over the years is that people tend to skip studying the early material. And this first section everyone should get 100% on, really. There's not really any reason you shouldn't at this point. We've been talking about objects the whole term. There's only a couple things that are a little tricky that you got to be careful of here. So a class defines a new object type, right? So you should understand a little bit about like what a class is actually doing. How is it stored? Well, all object types are stored as references, as opposed to primitive values, which are stored by just by value, right? We create a new object with new, and when it says actual objects here, it's like actual objects versus object variables. So you should definitely understand the difference between a variable of an object and an object itself. Instance methods are always applied to this object. So when we're dealing with an object that we have a method in, right? So if I have, well, I'll just use this example I already have here. So if I was to make an object of my, linked list recursion here, or let's see, my quiz linked list, what do I have? I'll use this int node. So if I wanted to refer to a method in my int node, I can just do this, right? I can just go get value, and you should all recognize that this get value in this object is going to call this method, right? Now, if I put this dot get value, these are equivalent statements, right? They're both going to get called the same way. This is optional, but you should understand that it's getting called kind of implicitly, like behind the scenes, right? What else here? Yeah, you shouldn't really write this unless there's a duplicate. You should understand how constructors work, that they create objects. There's no return type, and they have the same name as the class. And you should understand class variables and method defined using static. So you should definitely know how to use static. Now, if you look at this, you'll realize, oh yeah, and this stuff too. But you should realize there's not that many ways for me to ask you questions about this, right? So like chances are you're going to have to make a constructor, be a static variable in it, or method, or both. There's going to be some sort of thing where I'm asking how many objects are created versus how many variables are created. I like that kind of question. You should understand how references work, right? You should also understand visibility. So the difference between private, which is only this class file, protected. For our purposes, I know there's some like more detail here, but for our purposes, protected just means it's accessible in subclasses, and public means it's visible everywhere, right? So you should understand, and not only understand, but these you should be applying these. So if you're writing classes that don't have visibility modifiers, I'm going to dock a half a mark off, right? You should know how to use and how to write basic object methods. So toString, equal, and compare to. These are fair game. If I ask you to write a equals method or a compare to method on the exam for a class you define, you should be able to do that and understand what it means without me explaining it. What's the difference between shallow and deep copies?
Shallow just mean like it directs to the existing memory address, whereas with deep copies with the new objects, you will have a new memory address with the same content.
Yeah, and what's important about that difference?
When you modify with shadow copy, when you modify the new objects, you are actually modifying the existing one, where with deep copies, they are independent. So
Yeah, very good. So you can see there's an important difference there, obviously, right? The shallow copies are the same object and the deep copies are different objects. And you should be able to use these. So this is older material. I'm expecting a pretty high level of understanding with it. So you can definitely be expected to understand when and where it's appropriate to apply any of these things, really. You should be able to recognize, like, I'm not necessarily going to say write a static variable. I'm going to say solve this problem, and you need to be able to recognize, oh, this is where I would use a static variable. This is a deep place I should deep copy instead of shallow copy, right? System array copy, we didn't really cover this too much, but you should kind of know how it works. So that's section 1. That's the whole, this is everything I have to pull from here. So there's actually not that many different questions I can ask you. Does anyone have any questions about any of this? Either the content or what to expect, or no? Okay, major area 2, multidimensional arrays. This one's only 3 items, so it's really short. It's an array of other arrays. You should also recognize that the array is full of objects and that the array itself is an object. You guys did not do very well on this question on the midterm in general. A lot of people got it wrong because they know how to use a multidimensional array, but they don't understand what's actually going on. I'm definitely going to be putting some pressure on you to understand what is actually happening. So you should be able to tell me how many objects are created, what type of objects are created. You should be able to create multidimensional arrays in various ways. You should understand that int 4,3 means an array of 4 int arrays of length 3, right? So this is what I mean by the internal stuff. You should understand ragged arrays. So this is rows of different length. And you should understand how to initialize them. Again, did not do very well on this question. So you have to first set up the array. So this would be an int array object with 4 variables, but I haven't declared any of those one-dimensional int arrays yet. Right? Does that make sense? They're all null. So you have to specify this first size, but if I specify this first size, I can leave the second one blank, but it means that all the array objects inside it are also null until you assign them. So there's only so many ways I can ask these questions. So you really should be able to figure out like what I'm going to ask you. I also might make you iterate through the arrays in different ways. So you should be able to go through them like backwards, every second value, like stuff like that. You did a lot of multi-dimensional arrays this term. So I think you will be pretty good at them. But make sure you understand what they're doing internally, because that's often where people have problems. You should also be able to use multi-dimensional arrays of objects. It doesn't explicitly say it here, but I think that's implied at this point. Any questions? Okay, files and exceptions. So exceptions are objects. All exceptions are subclasses of exception. So you should understand both what this is doing and the implications of it. So if you want to catch all exceptions, you can catch an exception type. If you want to catch all subtypes of IO exception, you catch IO exception. We didn't really do this a lot, but you should know that you can create your own exception type and throw it. These are basically like standard object methods. So get message, prints, or exception objects, or exception methods. So get message, print, stack, trace, toString. We've covered this a whole bunch of times, so make sure you're using these properly. This is another place people lose easy marks. What else? Try catch, obviously. But again, don't just memorize the code. I'm going to ask you to explain yourself, right? You're going to have to explain why you're doing particular things. I'm going to give you scenarios and have you like try to understand or explain to me why you're doing particular things and what the implications are. So make sure you're able to answer that type of question about this stuff. Yeah, so how does the try catch block work? And also how to throw exceptions from the method as well, and when and where you might use that. Okay. Any questions? Okay, so files and exceptions. So file input, so new file reader. Again, I'm really highly recommending the file reader buffered reader method. So that's what I would sort of use. I would also say make sure you understand the difference between file reader and buffered reader and scanner, because scanner's not even in here, but scanner is something we spent a bit of time with, so you should know scanner as well. That's one of the things that's not in these notes. And so you should be able to understand the difference. Any of the methods listed in here are fair game. So, you know, there's not a lot. You don't have to memorize the entire Java API, but if it is specifically listed in this document, then it is fair game and you might have to use it or whatever. So the difference between read line and read, we covered this yesterday in the bonus class quite in detail. You know, print writer. So things that are not examinable, binary files, printf, we never really covered those, so those won't be on the exam. You can also like, generally I exam on the stuff that we spent the most time on a little bit more. So, but it might be outside of that. So make sure you kind of go through the notes anyway. But I'm basically drawing from the notes and the assignments, so, and the labs. So that's kind of where I would focus on. Okay, any questions? Am I going too fast? Nobody's saying anything, so I speed up.
You're good. You're good.
You're good? Everyone's good? Okay. Okay. Object hierarchies. So extending a subclass. How do they work? You're inheriting from the parent class or the superclass. Additional variables and methods you can add. How to use constructors. This in particular people have trouble with, so make sure you understand how this works, right? So super without parameters, we'll call the parent class constructor without parameters. This super will call the parent class constructor with parameters. The constructor has to be called first in the subclasses as well. That's a requirement. Subclass methods with the same signature override the superclass method. So how does inheritance work with methods? And how to call that method in the parent class. One thing particularly watch out for is the difference between calling the super constructor and the super method, right? This one's the method, this one's the constructor. They're slightly different. We did quite a bit of this as well with the chess pieces. Again, kind of some theoretical stuff. So subclass objects are instances of the superclass. So you can assign a subclass to a superclass, but not the other way around. Again, I always fall back on the person-student relationship to give you a concrete example of this, because a student has a name and age, but a person doesn't have a GPA, right? So the student, if you have a student variable and you call .getGPA and this is a person, it has no GPA to access. But if you have a person variable and it has a student GPA, it doesn't matter because the student still has a name and age. So basically the superclass can hold any subclass, but not the other way around. You should know last variables and how to use instance of. That's a bit more straightforward. The clone, toString, and equals method in object, you should know how they work, know how to overwrite them or override them. And so how do they work? You should know how to override them while maintaining the behavior. So especially like toString, if I say, hey, get the toString, but also print the toString of the parent, you should know how to use super to do that. And polymorphism. Now, again, polymorphism, people often think it's kind of all the inheritance stuff. Make sure you understand all the inheritance stuff up to polymorphism before you tackle polymorphism, right? And polymorphism very specifically is saying grab the correct method at runtime if both the parent class and or both the superclass and the child class have the same method, right? Now the method has to have the same signature, so both parameters and the method name. And this only works if the superclass has that method. Using an abstract class, so we didn't use it a whole lot. All it really means is that you cannot create an instance of that object. And it's often used to provide a superclass structure that you can then inherit from multiple subclasses. You can, however, create, a abstract variable, or rather you can create a variable of an abstract class that then holds subclasses. So it really only just stops you from instancing the object. That's really all it does. That's it. That's half the exam so far. Any questions on this section? We're cruising through this. Not yet. We're only on topic 4 of 8. We'll get there. There definitely is going to be recursion. Okay, topic 5, array lists. So they only hold objects. These are basically like array list X is simply an array list of type object. So if you're using this type, you have to be careful that you're always using instance of and casting the object back to the type that you want it to be. Or you can use the generic version, and then you don't have to cast as much, but you have to set it up with the generic tag. You're going to have to use instance of and casting quite a bit. These methods you should know. I generally try to give you an array list question, like for the long answer questions. I generally try to give you something that you can solve in multiple ways, but that's much easier to solve if you know these methods. So I would kind of just like make sure you know how these operate. And some of them are not super intuitive, so you might have to look it up. So just make a list, make some little comments on them. You should also know what they return. That's something. So what data do they return? How do they operate on the list? So what does the list look like after they're called, and what do they return? Yeah, I realized I forgot about that. You're basically going to get, in terms of the structure of the exam, you're basically going to get like 2 questions from each topic that are short answer questions, which are more like either theory, like written questions, or maybe finish a method, but they're like 2 markers. And then you're going to have 1 long answer question for each section as well. With the exception of the searching and sorting, which I'm probably not going to give you any long answer question for it, because A, it's too easy for you to copy the answers. And B, we didn't really cover it very deeply. So I'll probably just have, I'll probably have extra short answer questions for this section in lieu of a long answer question. 7 long answer questions. Now, my advice, especially when you're practicing, you should be spending, like, you can do the math, but if you're spending like 2 to 3 minutes on each short answer question and 10 to 15 minutes on long answer questions, I would say that's pretty good. That's a pretty good goal. And that would leave you some extra time at the end of the exam to go back and review everything. The long answer are, yeah, they're more like the lab questions. They're quite short, actually. You'll probably find them actually even simpler than the labs. They're more like the quizzes. So like the last quiz we just went through, those could be, well, those are maybe a little bit too simple, but maybe not. For recursion, that's probably actually a good skill difficulty. That would maybe be easy, but that's kind of the length of the recursive questions you can expect. Other sections might be a little longer, might be a little trickier. Stuff that we spent more time on might be a little trickier. But yeah, they're kind of short. They're probably shorter than you think. You can look at the sample exam. So I know I said that the sample exam isn't really a good guide, but it's a pretty good guide in terms of like the difficulty of the questions, in terms of the structure of the exam itself, in terms of the long answer questions. So these are, define a class bus. It has some variables. It has a static variable. I'm setting all the variables. It has a method that uses the variables. It has another method that also uses the variables. This one's a little long because it's kind of simple. Whereas something like this, so check array, you can, and I even have the marking here, and I posted this the other day, the solutions. So you can see as well, one thing to pay attention to, there's a marks for different things. So if you're not sure how to do stuff, it's okay to like do part of it. And I would even say if you don't know and you really are just totally stuck, just put in a comment with what you think you should do, because it helps me understand that you know what you're doing. You just maybe don't know how to write a one-line thing. But something like this is, these questions are probably pretty appropriate in terms of like the difficulty. You should see that there's not a lot of code. I don't really want you writing pages and pages of code. I'm more focused on you understanding how to write code. I am going to try to come up with, and they're always a bit like this structure. Like, there's only so many ways I can ask you about subclasses, for example. So you can expect to write a parent class, and you can expect to extend it, and you can expect to have to access the variables in the parent class, and you can expect to have to overextend the methods. There's only so many ways I can ask this. This hits like, when we're looking at the other document here. Like, let's just have a look at this for a second. So object hierarchies. Okay. So subclasses are instances of the superclass. Okay, well, we didn't explicitly look at that. Clone, toString, polymorphism. Here. So extends creates a subclass. Boom, extends creates a subclass. That's one mark. All methods and variables are inherited. You have to access those variables and methods. That's one mark. Super will do this explicitly. You have to call super here. That's a, and you have to call the other super there. So there's this, and there's method. So you can see here, I literally have like this page is one mark for each of these, and there's the 5 marks in one question. Okay. Does that make sense? Yeah, so just pay attention to how much time you're spending. If you're finding that you're like spending like way too much time on a question, I would say just like abandon it and move on, and then come back to it at the end. And sometimes something else will tip you off. Maybe another question will give you a hint, or you can kind of work out sometimes what the question might be about just from the other questions. Where were we here? So we covered array lists. Again, array list is one page. So this is one long answer question. I make you create an array list of a certain type. You have to use 3 or 4 of these methods to achieve some goal. That's a long answer question. So linked list. Okay, so node and linked list are standard classes. Oh yeah, well we're almost done. Do you guys want to take a break, or we're probably going to be done in like 10 minutes, 15 minutes. Okay, we can take 5 minutes here. Yeah, no worries. I asked a little while ago, so just say so before. Okay, so let's take 5. I need to refill my cup of tea. So we'll say 10 after, shortly after that, we'll get kicked out here and then we'll finish off pretty soon. We're almost done. Okay. Ready to continue? So next question, linked lists. So node and linked lists are our standard classes. You should be able to basically make these if I ask you to. I'll generally provide them just so that it's consistent. One thing to watch out for though is what I usually do when I do this is I make the node variables public just for the exam. Just so that there's not so much code I'm writing into the system. So just kind of watch for that. You should definitely know how the top pointer works, how links between nodes, how to use the structure of it. You should understand that it's easier to add a node to the start. You should understand how to sequence through the linked list. Now this might be next equals get link, but I could also say something like go every second node or stuff like that. If you need to use the previous node, for example, to do deletions, you know how to move a pair of previous and next references through. I won't ask you to draw a picture, but you should be drawing a diagram for yourself if you need it. It's very helpful for testing. That's really it for linked lists. Easier said than done, I guess, but there's not really a whole lot I can ask you about it. Again, I'm going to try to come up with questions that you haven't seen before, so don't be surprised if they seem a little odd or arbitrary. I'm just trying to come up with questions that are unique. So, but it'll use all the same stuff though. Another thing I'll maybe just add to this is I may ask you to compare and contrast the different data structures. So this would be like advantages versus disadvantages of a regular array versus a linked list versus a array list. So you should understand kind of like some pros and cons of each of them and be able to discuss, like, given a particular problem, which data structure would be the most appropriate and why, or this data structure is not a good choice for some other reason, and all that sort of stuff. Okay, does that make sense? Okay, any questions? You guys do not have a lot of questions for a class that's about to write an exam when the prof's sitting here telling you what's on the exam. I hope that means you all feel very confident about this exam right now, and hopefully not too overconfident. Dun, dun, dun. Okay, major topic 7, recursion. We're calling a smaller case of the same method. There must be an easy non-recursive base case. So recognizing the base case versus recursion, you should understand it works because of the execution stack. So we're stacking. We have in our stack, we have the first method called, and then we have the next method called, and then when this method returns, it goes back to the initial method. So in the debugger, when I shows you the method calls, you should understand what's going on there. When you're writing a recursive method, assume or trust that any smaller case will work because you know you're writing a correct method, and call the recursion. And think about how the smaller case can be used to solve the larger case. So for example, if I ask you to sum a list, well, the sum of a list is the first value plus the rest of the list summed. That's all that means. Add your easy base case. There you go, you're done. Tail recursion is basically equivalent to a loop structure. So you should be able to basically take a simple loop and convert it to recursion and vice versa. And you should be able to kind of discuss a little bit when recursion is or is not appropriate, and think a little bit about the algorithm complexity. So things like the Fibonacci sequence where it branches out. Understand that if you have multiple method calls, it might not be the best case. The recursive long answer questions tend to be pretty, I don't want to like pummel you with them. It's just enough to test that you understand how recursion works. So think more the lab and less the assignment, and probably, to be honest, even easier than the lab. maybe not easier, but smaller. I don't like having a lot of code written. It makes marking it a lot harder. I tend to make the question more complex and shorter if I have an option to do so. That's it. Recursion. Any questions? Searching and sorting. So we only have 2 searches, linear and binary. You should know the basic concepts of algorithm orders. So order n versus log n versus order n squared. Now you should be able to recognize which of these is which in different scenarios. There's also order 1, which would be like if you just check one value, that would be order 1. So you should be able to basically recognize what the order of an algorithm is. Okay. You should basically know a little bit about each of these sort algorithms as well. So insertion sort is we're removing the first value and we're putting it back in place in the right spot. Yeah, constant time would be order 1 would be basically like you're accessing a value directly. So if you have an array and you needed to access index 5, that would be order 1 because it's always like if the array is length n, it takes 1 step. It's not going through the whole array, right? If I had a linked list and I said I needed to access a value in the list, that would be order n. Okay, to see the difference? Because in the linked list, it has to go through the whole list. Yeah, so the sort methods we looked at, so insertion sort, selection sort. So the difference here is a lot of people get these two confused, so that's something to watch for. Insertion sort means we're putting the value in the correct place. Selection sort means we're selecting the smallest value and we're switching it into the front of the list. Looking at the faster order n log n sorts. So these, I'm not actually probably going to give you to do the code for any of these because it's too easy for you all to cheat on it. So shell sort. So this one's a little tricky, but this is one you're doing like large steps. Merge sort. I still have to give you a new video for this one. But basically this one is based on you're dividing the list in half and you're dividing it in half again. And then you're once the list is length 1, you're combining the list again together in a sorted, like, so they're in the right order. And then you can take these two small lists that are in the right order and it's very easy to like combine them in the right order. Quick sort chooses one element to be the pivot, splits into smaller and larger, and then sorts the two pieces. That's it. That's the end of the course. Okay. Yeah, so in general, you can expect 2 questions and a long answer question from each section. You can think about it from my perspective. I need to write 2 questions and a long answer question for these 2 pages, say. So chances are I'm going to combine, like on your long answer, each of these points. I'm probably going to ask you about all of these points or as many as I can. And each of these points you can think of as going to be worth 1 or 2 marks. So if I have a long answer question, it might have like all 5 of these points in it, and that would be worth 5 marks. So try to get as much as you can. Like I said before, there's going to be a bit of an emphasis on understanding and theorizing about some of this stuff just because of the way the questions online are structured. So you can definitely expect questions like, you know, compare and contrast these 2 algorithms, or which of these data structures is most appropriate for a given scenario, or why would you do a particular thing? So just be kind of ready to explain your answer is maybe the best way to put it. And I don't want a paragraph. Like my answers on the solution are going to be like a line or 2. So if you're very clear and you're very explicit, you shouldn't need like pages and pages of explanation. If you find especially the short answer, if you find you're spending like more than 5 minutes, you're spending way too much time and you should move on. I don't know what else I could tell you. What else do you want to know? Does anybody have any questions? Yeah, you could definitely have clone. That's in there some. That's in. Where is it? Here. So clone toString equals method. So you should be able to write your own version of these methods, not just using them. Okay. Well, if nobody has any questions, we're done. If you think of any questions, you can. That's it. Good luck studying.